Hey, it's Chris McCord, and today I want to show you how easy it is to use the new Phoenix LiveView Uploads feature by taking you step by step to adding uploads to an existing application. We're going to show how you can upload files directly to a server and then take those bits, copy them somewhere locally on disk, maybe take them from the server and then push them off to some network storage or cloud storage, and even how to then go and upload files directly from the client to a cloud storage service, and being able to use the same code paths through Phoenix LiveView Uploads to make all this happen. And so to do this, we're going to pick up where we left off on our Chirp application, which is a Twitter timeline clone, where we can have this kind of social timeline. I can retweet things, I can like things, and whatever I'm doing in one browser is going to be propagated to all the other browsers that are connected. So what I want to do is be able to click new post and then have a file input here and attach photos to my post, and then have those show up on everyone's screen that's watching, with file progress, with image previews, and everything you would expect from a modern application. So to get this going, let's go ahead and write a little bit of code. So if we go into our form component, we can see how this works. So the very first thing I need to do is declaratively allow an upload to occur. So what I can do is say, for this component, when I mount it, I'm going to allow uploads to happen on this component. So I can say allow upload, and I'm going to name the upload photo, because posts have photos, and we have to provide what kind of files we accept here, because this will be enforced at the metadata level. So here we can say we accept PNGs, JPEGs, and JPGs, and we can also enforce the maximum number of files that are selected. So by default, Phoenix LiveView enforces one file. But the nice thing about LiveView Uploads is to go from single file to multi-file uploads, none of your code changes. You just enforce it at this level. So it's a single code path, whether you're supporting a single file selection or multiple files. So we'll say we want to allow 2 photos to be uploaded for a post. They have to be PNGs or JPEGs, and then that will provide some new data to our template. So if we go into our form template, we want to render an input tag underneath the text area. So here's where we can say live file input, and we can provide this new uploads assign and then the named photo upload. So I can say provide my uploads.photo to this, and it has all the information it needs to properly render this input tag. But if you notice, if I actually try to use this, nothing is going to happen here, because I need to render data in my template just like anything else. So let's render some information about the files that we've selected, and we should be able to see them show up. So I can go through the entries that the client has selected. So I can say for entry and uploads.photo.entries, and we can go ahead and render information about the files before they're uploaded. We'll have the metadata, the types of files, and we can even render previews of those files. So we know right away that we want to render a few things. Let's say we're going to render 3 different pieces of information. So we'll have the photo preview, we'll have some progress information, and then the ability to cancel a file upload before I've actually saved. So here I can say, let's render a preview of this file with a live image preview function. And this is going to render client side a preview of that image before uploading anything to the server. And then we can give it, let's say, a fixed height of 80 pixels. And then we also want to render progress, and I'll just use the progress tag for that. And it's a percentage value, so we know the max is 100, and the value itself is just going to be the entry.progress, which is an integer value. And like anything else in LiveView, is anytime the template data changes, so anytime any information about these selected files to be uploaded change, the template is partially re-rendered, and then a diff is sent to the client. So anytime file progress changes, this progress is just going to be re-rendered, and we're going to send a tiny bit of integer information on the client to update the UI. And we'll see that working in a moment. And then lastly, we want to render some kind of cancel button or link to be able to prune files before you make your final selections to submit. But let's see where we're at right now. So let's select some files, and we can see immediately they show up. We've got these images that are rendered on the client. Nothing's been sent to the server other than metadata about the file. And the progress is all 0 because nothing's started yet. But if you notice that I have selected 3 files, and it's already this is exceeding the constraint of the 2 max entries that we added. So we're in an invalid state, but we haven't provided that feedback to the user. So I can say check out these planets, and if I try to save this, you can see that it rejects the submission because the client knows that this is already invalid. So we need to provide that feedback to the user in order to continue. And we can just do that by rendering some information. So let's go ahead and just render each error message that is in our upload. So I can say for each message in the uploads.photo.errors, and let's just render some error information. This is something that you can localize in your application. It's going to be an atom like too large or invalid file type. But for us, we're just going to humanize that to something human readable for now. But this is something that you would normalize in a production application. But I'll just say, you know what, convert that to something human readable, which is good enough for our demo. And now if we try this, I'll select too many files. We can see immediately that message was rendered as too many files. So now it's up to the user to go ahead and prune this down to make their uploads happen. So we need to provide this cancel button. That way the user can prune files back down and be in a valid state. So here I'll just send in a simple event to the server. I'll just use an anchor tag and we'll say phx click equals cancel. We'll say cancel entry, and let's give it, we need to give it a value of the specific entry that we want to cancel. So I can say Phoenix value ref, and we'll give it the unique entry reference that just uniquely identifies this entry. And since this is a component, we need to provide a target, and the target is going to be the component itself. So the message goes to the component and not its parent LiveView. And now if we go into our form component, we can handle that event by pattern matching on the event name. So instead of save, we're going to pattern match on cancel entry. We know that we get a parameter value of reference, and that's the entry ref. And here's where we can say no reply, and we're going to say cancel upload, provide the socket. The name of the upload is photo, and the entry reference will be that reference. So now if I save that, we should be able to prune our invalid entries down. So too many files, let's say not this one, and now we are in a valid state. Our markup is a little bit messed up, so let's go see what we messed up there. We need to close this anchor tag. Okay, so let's see what this looks like with valid markup. Okay, so now we've got too many files, and if I prune them, as soon as they become valid, the error went away, because again, LiveView is just going to re-evaluate this code, and it removed that alert, and that alert went away. And now when I save this, these uploads should occur and be sent to the server. So I can try to persist this and say check out these planets, hit save, and boop, they immediately got uploaded. And it was super fast because it uploaded to localhost, but you can see that nothing was persisted because they went to a temporary file and then went off to the abyss on the server because we're not consuming them. So our next step is actually handling and consuming those bits that were uploaded to the server on save. So that's going to take just a little bit of work here, and then we'll go from local server uploads to direct to cloud uploads afterwards. So what I need to do is a couple steps here. So we're going to start simple, go directly to the server, and then see how we can go direct to cloud after that and how little code it takes to go between the two. So to go directly to the server to upload files, we need to create some place for those uploads to live. So I'll just say priv static uploads is where this is where I'm going to upload files to. And I also want to persist these the location of these files to the database. So I'm going to need a migration. Let's say add photo URLs to posts. That's gen migration. Okay, so that exists, and we have to do a few things to allow files to be served that we upload. One is go into our endpoint and say that we can serve static files out of the uploads directory. And we also need to, in development environment, not reload the page if we find the uploads have been uploaded. Otherwise, every time we upload a file, the page is going to refresh because live reload is looking for any changed asset, but in this case, uploads are not assets. So we'll say ignore the uploads directory. Okay, And then we need to write our migration, and that should be in the priv repo migrations directory. It was add photo URLs to posts. There it is. And then we can say, let's alter the post table. We want to add a column. We're going to call it photo URLs. It's going to be an array of string. Let's add a not null constraint, and let's default it to an empty list. And then likewise, we need to update the post schema to map that database column back to the Elixir data structure. So the field is going to be photo URLs. It's going to be an array of strings, and the default is an empty list. And we're not casting this to user input, so we'll set it directly. So this is all we need to set here for the schema. Okay, so now let's go ahead and migrate up, see if we're good to go here. Mix-ecto.migrate. Okay, so that's looking good. Let's go ahead and restart our server. All right, so one thing we need to look into is when you submit a form, and Phoenix has a Phoenix submit on that form. So if you want to submit a LiveView form, it's going to send this event to the server. And what LiveView is going to do internally is if it sees that there are any live file inputs for a form, it will wait for those files to be concurrently uploaded before triggering this event here. So we can know that when our LiveView component itself receives this handle event save, that all the uploads are necessarily done waiting for us to consume them. So all we need to do is handle those files when save is called. And there are a couple different branches happening here when we save. Looks like we're saving, we're calling timeline update post when we edit an existing post, and we're calling timeline create post when we save or try to insert a new post. So we need to go ahead and have some shared code path here that calls into actually consuming those that post information. So we know that ahead of time we need to save these photo URLs as that database field that we just added. So we can go ahead and put those values inside our post here. So we know let's write some shared function. Let's say it's going to take a post and return a new post. We'll just call it put photo URLs. It's going to take our socket, and let's say our socket assigns.post here. And then this is going to receive that updated post. And I'm going to do the same thing for when I try to create a new post. I'm going to pass in a brand new post here, and it's going to then be populated with photo URLs. That way when I insert it, it's then going to have the values in the database. Okay, so step one, we need to write this photo URLs function. It takes our socket and it takes a post. We'll pattern match on that. And then all this needs to do is read the entry metadata to figure out what the photo URLs are ultimately going to be for these files. So what we can do here is we can get all of the completed entries. So Phoenix LiveView has this uploaded entries function. And we know that we want to get the uploaded entries for the photo upload. And this is going to return the completed entries and anything that's in progress. But remember, we know that when save post is called, that everything should be completed at this point. So we can go ahead and pattern match on that explicitly. And then I can just say generate some URLs for each entry. So I can say for entry in all those completed entries. And we know that whatever we return needs to be populated in that post. So we'll update our post struct, and we'll set those photo URLs as whatever the URLs that we generate. So now we just need to populate this comprehension here. So in this case, we are uploading our files directly to our local web server, at least to start with. So we can make use of the route static path helper. Since these are going to live locally, they can just be a local file path. And that takes our socket, and we are saving these to priv static uploads, which gets served from the root uploads directory. So this can be /uploads, and then we just have to figure out how we want to name the file. But since LiveView populates an entry with a UUID to uniquely identify a file, we can just piggyback off of that. And it's also nice that this is guaranteed to really be globally unique. So this is a perfect thing to key off of to save our file name. So we'll save this file name itself as the entry UUID that LiveView generated, and then we need to provide some valid extension for the file. And here I can lift this off of the entry metadata. So I'm going to write a function, let's just call it ext. It takes the entry, and then it's going to just do a couple operations to generate a valid file type for that entry, because we can rely on the client's file name, but the file name may not have a valid extension that maps the actual MIME type of the file. So what we're going to do is write a function that says, given an entry, I want to return a valid extension based on the MIME type that the client told me about this file. So here I can just make use of the MIME library that Plug and Phoenix use internally. So I can say I know that there are multiple valid extensions potentially for a MIME type, but just use the first one here. So I can say MIME.extensions given the entry.client type. So the entry's client type is going to be MIME type of that the client said this file was. So we'll just generate and grab the first valid extension that MIME's aware of for that and return it. So then the final URL is just going to be /uploads a UUID dot a valid extension for the MIME type. So now these should be populated, and we just need to consume those files. So the final step here is we have a post that has valid URLs. We're going to persist that to the database, but we need to consume those files and move those bits on disk somewhere. And we really only want to do that if we had a valid persistence take place, right? So we could do that here and consume the files, but if we wait, at this point we've already broadcasted internally that this post has been updated, so we would need to move broadcast out. But instead I'm going to allow the callers to provide some kind of function to run after the fact, after a successful insert or update, and then they can do the work there. So we're going to have the caller is going to be allowed to, let's say, return a function. What we want to do is say consume photos. We'll pass our socket in, and then it's going to also provide us the updated inserted post. And then we're going to do the same thing at the create post level. So when we create post, it's going to now accept an optional function to run after the persistence occurs successfully. And we'll write this consume photos function in a moment, but we need to go ahead and update our timeline context to support this new feature. So here is where I can say I'm going to accept an optional after save function, and by default let's just say that is just going to return OK and the post that was returned here. So by default, let's say the callers have to return a value of OK and the post if they want to change the post here. And what I can do is, after the insert, before we broadcast, I can call a private after save and pass in that function. And that after save function is just going to invoke the callback if we had a successful persistence. So I can say after save, if it was OK, post was the result, and our function, then we are going to call the caller's function, and we expect them to return a successful result. So they have to return something that is successful, or the operation is going to fail completely. So here we can just invoke their function, pass the post in, and likewise if it returns something other than OK, there was an error, and in that case we're not going to invoke their function because something went wrong. So that should be good there. So then what we need to do is go to update post and do the same operation. So we support an after save optional argument. After the update, we're going to call after save, and we're going to pass in that function. So here we need to write the consume photos function to close the gap, move those bits on disk. So nearly done. Let's write the consume photos function. It's going to take our socket and a post. And we know we need to return OK post at the end to abide by that contract. but let's see where we're at. We've written a lot of code. Are we in a compiling state? Okay, no, but nothing's complaining. So now we need to consume these files. So what LiveView provides us is the ability to, in one step, consume any files that are waiting for us that have been uploaded but aren't committed. So in one step, we can move those bits on disk, move them to network storage, take those bits, async them to some process doing, let's say, some thumbnail generation, whatever we need to do. And then as soon as a function is going to run, then it cleans up after itself. So this is going to allow no file descriptors to be leaked, no temporary files that you have to clean up on your own. It's just our chance to say that we are committing these uploaded files to wherever they need to go. So we can do that via the consume uploaded entries function. It takes our socket, the name of the upload, which is photo, and it takes a function to call per entry, and that is going to receive some metadata about the file upload and the entry itself. And it's again our job here to take those bits that have been uploaded to the server and do whatever we want with them. In this case, we're going to save them locally, but this is also an approach you would take if you wanted to go to the server first to operate on that file, to do thumbnail generation, to do post-processing before you ultimately upload it from here to the cloud. So you can still do cloud uploads going through the server in some use cases, but we're going to do direct to server, and then we'll see how to change this to go directly from the client to cloud storage in a moment. But all we need to do in our case is copy this file, temporary file, to some final destination that we're serving from our web server. So we know that we have some final destination path, and we know where that lives. That's going to be in the local priv static uploads directory. And we want to join that with the name of the file. And if you recall, what we named that file was the entries UUID dot some valid extension of that entry. That's a function we wrote earlier. So it's going to be some UUID dot PNG dot JPEG, and the URL of this then, or I'm sorry, the local file path of this then is contained in this destination. And all we need to do is then copy the bits on disk from the temporary path. So that's contained in the metadata. So metadata has a path which points to the temporary file. We're going to move those bits to the destination path. And then that's it. Once this function runs for all entries, all the temporary files get cleaned up and pruned and removed. And we've consumed those entries. The data gets uploaded inside the upload, the UI updates, and then we return our post to accommodate that after saved contract. So now when we call create post or update post, this function is going to run afterwards, which moves the bits on disk if persistence was successful. The broadcast is going to happen, and everything should update. So really our final step is just rendering those on the server, because we're not rendering them in the template. So this may work, but we don't show them. So let's do one final step to actually show this on the page. So if we go into our post component, you can see we're rendering the post body here. Let's go ahead and beneath the post body, just add a new row, or in this case, we can add a column. And all we need to do here is render out some images. So we know that a post has photo URLs, so I can say for URL in post.photo URLs. And in our case, these are local file URLs, but if they were S3 URLs, the code will remain unchanged. So for now, we just render an image tag. We say the source is whatever that URL is, and the height or width can just be a fixed value. Let's give it 150 pixels. Why not? And if we save this, this refreshed, we don't see any photos because nothing has been uploaded or persisted yet, but let's see if this works. So I'm going to say new post. I want to upload some planets, so I can say check out these planets. And I'm going to choose a few files. Let's say select too many files, prune. Now let's try to upload this. Save. Whoop. And boom, there they go. So now we have this in our browser, and we have this in anyone else's browser that showed up. And since we broadcasted the post information, it contained those URLs. So when it showed up on everyone else's screen, those image URLs existed, and it just arrived. So not bad. So that's file uploads directly to the server. So now let's take this one step further and see how we can go directly from the client to, let's say, S3 storage or Google Cloud Storage or any other cloud storage you want, and see how easy that is. And the coolest thing is the same programming model for LiveView uploads applies if you're going directly from the client to some cloud storage and bypassing the server. So we're going to do S3, but this approach will apply very similarly to really any cloud storage. Anything that has the ability to go from the client to get some bits on the wire supports the approach that we're going to do. So what we need to do is pass a new value to our form component allow upload. So by default, Phoenix is assumes that you want to upload directly to your server, but you can tell it you actually would prefer to go to some external service. So here you can say external, and then you could pass a function to call to generate some kind of authenticated token or pre-sign some data that the client's going to use then on your behalf to call out to an actual cloud service directly from the client. So here let's name a function, let's say pre-sign entry, and it takes a couple arguments. Let's format this to make it a little nicer. And then for each entry, it's going to, let's say we want to pre-sign some data that actually gives the client some cryptographically verified information for some cloud system. So we need to write a new function named pre-sign entry that takes our entry information and generates some values for the client to then pass off to S3. So locally, I have a library that just does a simple S3 encoded form, and you could use that. I'll provide a gist link to it in the notes below. But essentially, it's a snippet that I'm not going to explain here, but we'll walk through the code. I've saved this previously, so we can say chirp.s3 presign, and then we'll walk through. This is about 25 lines of code. But what this is going to do is for every entry, it's going to call this function that we passed, and the job of this function is just to not upload the file, but to pre-sign some data that gives the file something to pass off to a cloud service that verifies that yes, they can perform this upload. So in this case, we're just getting the entry in the socket. I'm generating a key for the file, and the key that we want to put on S3 is just going to be the UUID and the extension of the entry, similar just like we did for the local file upload. We've got our bucket name, some configuration that pulls out our access key, and then I'm using this simple S3 upload that generates this sign form API that allows us to upload directly from the client. And it's cool because we can enforce a MIME type, and then we can also enforce maximum file size. So that way S3 will actually deny a upload that is too large, so we don't have to worry about the client getting a token, uploading a file too big, and then us having to clean that up later. And then we expire it for in 1 hour. But the trick about this is we need to provide some information to the client side so it can go ahead and upload this file now. So the job of the pre-sign entry function is to tell the client, one, what's the namespace of the uploader that you want to use. In this case, we're going to tell it we're using the S3 uploader. And then any information we provide otherwise is returned as metadata to the client. So we tell the client, here's the S3 object key that we want to use. The S3 host is our bucket name .s3 Amazon AWS, and then the fields are those cryptographically signed form fields using the AWS sign form API. And this data is then sent to the client, and you have to write a little bit of JavaScript to wire this together. So most likely the community has provided the facilities for this for you, but I'll walk you through what this looks like for S3. So if we go into our app.js, it's going to take a very small amount of code to make this happen, so we'll just walk through it here. It's going to be chirp.s3js. And in this case, we're defining an uploaders object, and then here's the name of that uploader. Remember, I said S3 here, telling the client side what object to use. And all this does, and you don't need to be super aware of this because someone will likely have written this for you. The LiveView docs actually show you code that works with Google Drive, that works with the Mux API, and several others. And then what you're seeing here works with S3. But those entries contain metadata that we generated, such as the key, the host, and we're just going through each entry and generating this form data API that just abides by the S3 form data protocol. And then we're just using a AJAX request to send this file to the server, and then we report progress to LiveView. So we're saying that we want to report progress anytime the AJAX request says that it had progress, and then we send this off to S3. So that's it. So about 20 lines of JavaScript, and then we tell LiveView that our uploader's namespace is that uploader's object. So now it should be able to find that S3 object and let it do the work and have it report back to us the progress. So we had about 25 lines of code on the server, 25 lines of code on the client to send to S3, and now all that really needs to change is just our URLs that we are saving to the database no longer point to a local file path, right? They point to S3. So we just need to change our functions to give the proper S3 URLs. And really all that is just very similar to what we did before, but instead of sending, the static path local path, we're just going to, join, let's say we have a S3 host function, which is our AWS host name, and we have an S3 key that we use in our presign function, and we'll just provide the entry. And remember that S3 key here just takes the UID and the extension. So now our URLs are going to be the S3 URLs, and then we save those to the database. And then when we consume the photos, this is really just telling LiveView that we have handled them. We could go ahead and operate on the S3 URL here and do any other operations, but in this case, we just need to tell LiveView that we've consumed them, they're done, please clean them up. And that should be it. So now let's see if we have direct to S3 support. And remember, this is going to enforce client-side constraints. This is going to enforce maximum file size. It's going to go directly to S3, but it's still going to report progress. It's still, your template code will not have changed at all if we wrote this correctly. So let's find out. So I'm going to go ahead and say check out Earth and Mars from S3. Let's select Earth and Mars. There they are. See what happens. Okay, so that looked like it worked super fast. Let's check the URL to see, did this actually go to S3? And there it is, S3, Amazon AWS. And it just worked, right? We didn't change any template code at all to make this happen. Our allow upload just took an external function call, and then we wrote a little bit of code to pre-sign the URL and some JavaScript to get those bits from the client directly to the cloud. So that's it. That's a whirlwind tour of LiveView uploads, but I'm excited to see what folks do with this. You could take the file, process it on the server, do all kinds of really neat, interesting things on top of these primitives. So let me know what you think, and I can't wait to see what folks build with this. Thanks a lot.